Right now we're going to be looking at volume. Find the volume of each figure. Now, volume, for us to understand what's volume, is the space inside. Imagine a swimming pool. Okay, so imagine the swimming pool. Last week we talked about surface area. So surface area is like if you're gonna change the plaster, you're gonna paint your pool or something. The edge, the area, the surface area, that's the edge. Now this week we're moving into volume. Volume is the water that's inside the pool. All right. So again, volume is the space inside a solid, right? A solid is a 3D image. So we're looking at volume, the space inside. So we're going to be looking at our notes from 9 through 12. But before I look at our notes, before I look at our homework, or I mean our notes for today, let's take a look and understand what actually volume is. So let me share this image with you. Let's say I have this cube right here. Okay, let's say I have this cube. You guys see there's blue, orange, and red. Now volume, I'm asking how many cubes are in there? What's the space inside? So a couple of things we could do. First of all, I could come over and I count the blue cubes that I see here. I see it has the shape of a rectangle. It's a 2 by 4. So I see that there's 4 blue cube. I mean, 2 by 4. That's 8 of them. My bad. There's 8 cubes. Let me erase this real quick. Let me make this better. So there's 8 on the cubes, right? I'm assuming on the orange, there's some that I don't see here because there's some on the back, but I'm assuming there's 8 of them as well. Right, there's 8 orange cubes. Again, I don't see them all because there's some on the back, there's some under the blue cubes. And then from the red cubes, I'm going to say there's also 8. So volume is how many cubes are in there. Now, if I add all of these, I'm just going to say there's 24 cubes. All right. Now, let's say one of these cubes was feet by feet. We're going to use feet cubed. Okay. So for volume, our exponent is to the third. So if we were using centimeters, centimeters cubed, we're using inches, inches to the third powered. So feet to the third. Sometimes people call it feet cubed, or sometimes people call it cubic feet. Right? It's just how we speak. In reality, what we just do here is I'm going to come up with the formula for volume. It's going to be the area of the base. So I'm going to use B for base. If you notice, that's what I did first, right? The base, it was a rectangle, of a 2 by 8 rectangle. So we figure what was the area of the base. And I could have just multiplied this by the height. I could have done volume is area of the base times height. Right? And we would have gotten 24. Let's take a look at a figure. Let's say I have this figure here. You guys see I have a solid here made out of cubes. So I'm just going to look at the base. The base, it could be on the top, could be at the bottom. For today, we're looking at prisms or cylinders. So we talked about last week that there's 2 bases, one on top, one at the bottom. So I'm looking at the base first. My focus is right here. I'm going to say there's 6 of them. Remember, area of volume is going to be the area of the base times the height. The area of the base is 6, right? How many cubes are there in the base? It's a 2 by 3 rectangle, so it is 6. I see I'm going to look at the height of this. There's 1 base, there's 2, there's 3, there's 4, there's 5 bases. So that means the height is 5. Let me just say that the height here is 5. So in this case, if I had this figured, I could break it down into cubes. I could break it apart and count all the cubes, or I can just multiply the area of the base times height, and I will say there are 30 cubes in this solid. So what I'm going to be doing is area of the base times the height. Even if I do have a cylinder, my cylinder, I can break it down. They have a cylinder. I can break it into the base. In this case, is a circle. I can break the bases and then just multiply it by the height. So again, I'm going to go area of the base times the height. Okay, now that we understand this, let me come back to our notes here, questions 9 through 12. Looking at 9, I'm going to start by looking at a shape that is not a rectangle, right? Because that's going to be the area of the base. So I can see I have a trapezoid. First thing I start looking again is at the base, because I know volume is going to be the area of the base times the height. Okay, so the base is a trapezoid. So I got to remember how to get the area of a trapezoid. I remember for a trapezoid, my focus is on the two sides that are parallel. So these two sides. Using red, I'm going to say my measurements, one of them is 9. I know this side is 9, right? Because I got the 9 from back here. And this other side right here, it is 4. So I know I have to go 13 because I added the two bases. So 9 plus 4, that gave me 13, times the distance between the bases, which in this case is 4.3. Then I know I have to divide this by 2. Remember, that's how we do the area of a trapezoid. We saw that a few weeks back, so we should know how to do this. I added the bases, I multiply by the height of the trapezoid divided by 2. All of this, let me put a big parentheses, that's going to be the area of the base. Once I finish this, once I figure what the area of the base is, I'm going to multiply this by 12. 12 because that's the height. Remember last week when we were talking about surface area, I said height is the number that has nothing to do with your base. This 12, if I was to stand up the base, I was to stand up the solid on the base, so the base at the bottom, the base on the top, 12 is the distance between the bases, so that's the height. Some of you might be saying, well, what about this 5? What about that 5? I don't need it. That is actually one of the sides of the base, so that's not the height, but I don't need that 5. So I'm just going to multiply 13 times 4.3 divided by 2, and then my result, I'm going to multiply by 12, and I happen to get 335.4. If I'm looking at feet, the measurements, notice how I have feet. All the measurements are feet. It's going to be feet cubed or cubic feet. Sometimes people call it like that. Now, sometimes your answers are going to have a long decimal place. So we're going to round it. Keep on your instructions. Here it says round your answer to the nearest 10th if necessary. So I just rounded to the nearest 10th. All right, so now let's take a look at number 10. I know for circles, I need to know the radius. I'm going to say the radius in this case, let me change back to blue. I'm going to say the radius is 7, right? You guys can see the whole diameter is 14, but the radius is only half of it. So the half of 14 is 7. So I know the radius is 7. So I'm going to say, oh, all right, how do we get the area of a circle? I'm going to go 7 times 7, because I have to go radius times radius. So 7 times 7 times pi. All of that is the area of my circle, right? The area of the base. Again, I'm going to use the number pi, the symbol pi. So my calculator, I'm going to type in pi. For those of you that are using EDIA, the calculator on EDIA, you guys can type in the letters PI, and then the symbol pi is going to come up. So if you guys are using EDIA, the calculator from EDIA, that's how you type in pi. So you guys can use pi or use the pi symbol. I'm not going to round it as 3.14. I'm actually using the whole pi, which is like 3.1415927 and on and on. I'm using the entire number pi. All right, so I got the area of the circle, 7 times 7 times pi. Whatever I have for this, I'm going to multiply this by 11. Let me emphasize that the first parenthesis is the area of the base, and the 11, that's the height. So I'm just doing area of the base times height. And that gives me, I'm going to round my answer to 1 decimal place already. My answer will be 1,693.3. My answer actually came out as a long, long decimal. I just rounded to the nearest tenth because that's what the instructions said. If it said rounded to 2 decimal places, then I will round it to 2 decimal places. All right, let's take a look at question number 11. Now I see that here all of them are rectangles. One thing I can do is choose any rectangle as your base. It really doesn't matter which one. Let me choose the one I see here. That's going to be the base. So in this case, my base is going to be a 4 times 12. Right? It's a rectangle. In this case, I chose that as a base, so 4 times 12. And then the height, the number that has nothing to do with my base, is going to be 7. Now I'm just going to go forward times 12 times 7, and my result will be 336. Now, wait, let me come back over here. Some of you might be like, Mr. Leonzo, I actually saw this little rectangle here as the base. Is that okay? Yes, we got choices. If that was the case, you can see the other base down here, right? You can see those is going to be your base. So that one, you're going to go 7 times 4. That's going to be the area of the base. And the height, in this case, will be 12. 7 times 4 times 12, it happens to be 336. So when we have a rectangular prism, that means the base is also rectangle. It doesn't matter which one you pick as the base, okay? Just, we're going to go area of the base times the height. Next to the result, it will be 336 as well. So same thing. Now let's take a look at question number 12. Now here, I don't have a choice as in I can choose anything to be my base, because on prisms or cylinders, prisms and cylinders, as soon as I find a shape that is not a rectangle, that has to be the base. In this case, I see a shape. Let me highlight it. I see a shape that is not a rectangle. My 90-degree corner is made out of 3 and 4. I'm going to say this measurement there is 4. You guys can see where I got that 4 from. So for my triangle, I know I have to multiply the two numbers that make the 90-degree angle. So 3 times 4. But because a triangle is half of a rectangle, I'm going to go 3 times 4, and all of it is divided by 2. So 3 times 4 divided by 2, that's the area of the base, right? The area of my triangle. Now the height, I'm going to do the numbered that has nothing to do with my triangles. The distance between my two triangles, which in this case happens to be 1. I'm looking at this 1. All right, so I'm going to go 3 times 4 divided by 2 times 1. My answer in this case happens to be 6. For volume of prisms and cylinders, I'm just going to go area of the base times the height.